Wes, close the door for me.
I'm actually trying to learn Japanese.
Oh, yes, I'm starting Japanese. Oh, yes, I'm starting.
How many other languages do you know, Seth, other than Russian and English?
Well, how are you going to define no?
Well, okay,
I define no by being able to fully.
Like one word in the language? Is that no?
I'm saying like you can pronounce an actual sentence, like a correct.
He can't. You don't read Cyrillic.
I can't. I understand.
I can read a little bit of Hebrew.
Okay,
You don't.
speak more French than I can German, so I won't count German. So I got French under my belt. I got Dutch under my belt.
Oh, we got to test that.
Let me test.
Well, we're about to do it.
I know the most about Russian.
Oh, thanks for raising your hand and slipping in Russian.
English? Probably know less than all my other languages combined. But I just know snippets from all these different languages, like random words.
All right, read it. Read number 1.
Oh my God!
Right, but it doesn't tell you how to read it. Go ahead, number 1. Do it. Read it.
I am. I have it.
Say it again.
Everybody's loud.
No. No.
What?
Read number 3.
He said no. He said no.
No. All right. So French, no. You said you can read German?
I can't read German. I can read Russian.
You read Cyrillic?
What?
You read Cyrillic?
Russian.
That's Cyrillic.
That's like.
You're confusing me.
Read it. Number 1.
Okay. Yep.
Read number
I don't speak da.
Oh my God. Go to someone in demon.
Oh, I just know my Russian.
read it.
Stop.
Yeah, it's really.
That's if you go to Russia, that's what their stop signs look like.
It's really.
The letter C is the letter S.
You know how you say sister?
Oh, by the way, guess what this last letter is? It's pi. They have the same letter, the Greek one. So there you go. P's are actually R's in Cyrillic.
And B's are B's. If you see a B, you pronounce a B.
Yes, you should search up Russian cursive.
Russian cursive?
I don't know if there is such a
I
thing.
don't think there's such a thing.
Is there?
I think for detention, to make us do Russian cursive.
They're Russian.
Oh,
Well, there you go.
Nah, that first one, don't even say nothing.
I believe that probably. Whoops. Never mind. All right.
What is that? Yo, I can write Russian and do it.
All right. E-learners are probably wondering what the heck is going on.
Oh, this is pretty educational.
All right, homework, get it out. I'm impressed. I didn't think you could read Cyrillic, so I'm impressed.
Yeah, I said I never said I can.
You certainly can't read French.
I can't read French. I know how to insult somebody in French.
Say it. You should insult Micah.
Just call someone La Couchon.
So if we ever go to France, I can insult somebody.
Yeah, that's what I was. Yes, let's go to a foreign language. Let's just immediately start saying offensive words.
Yes. Start fighting.
Pull up. We're gonna do.
All right. Any questions on the homework before we grade it?
Yes.
Hold on.
Questions on the homework before we grade it?
Actually, I have a question on 8.
Number 8. Let's take a look at number 8.
I'll just do 8.
Yeah, I was confused on that one.
Number 8 says the following. It says if AB is equal to 5 minus x over x. 5 minus x over x. Then A plus B over B is equal to what? So I'm just going to say finger. I'm just following the pattern. This says take A plus B over B. A plus B over B. A plus B over B. See what I'm doing with my finger? I'm doing the same thing to this one. A plus B over B. A plus B over B. So use my finger. This is A. A is 5 minus X. What's the next thing I did with my finger? I said A plus B. I did it wrong with my finger, sorry. A plus B over B. So B is, so A plus B. So this is A plus B all over B. Simplified. Minus X and an X. You got 5 over X.
I didn't do it like that. I just wrote it.
I like this section. It's easy.
Yikes, that's not what I got.
I said that for this particular section, that for those of you that can follow a pattern, it's not bad. For those you can't follow a pattern, it's bad.
What'd you get, Michael?
All right. Did that make sense, Michael, what I just did?
Michael, let me see it.
All right, here we go. 1 through 22 all, very quickly. Number 1 is 6. By the way, we did that one in class. Number 2 is 28. Number 3 is 21. Number 4 is 36. Number 5 is 4 over 7. Number 6 is 8 over 3. 7 and 8 are the hard ones. 7 is y plus 3 over 3. And then we just said 8 is 5 over x. All right, the rest were just cross multiplication through 20. They wrote their answer is a mixed number. It's fine if you put it in a proper fraction. So they're claiming number 9 is 2 2/5. If you put 12 over 5, that's the same answer. Number 10 is 10. Number 11 is 14 over 15. Number 12 is 20. Number 13 is -3. Number 14 is -1/3. Number 15 is 2. Number 16, they wrote it as a mixed number, 2.5, but if you wrote 5 over 2, same answer. Number 17 is 11. Number 18 is 44. Number 19 is 3. And number 20 is 20 over 33. So then we have this table of pain thing for 2 questions. So each one has, what, 3 answers? So on 21, I'm going to go from left to right. The answers are 21, 12, and 28. And on 22, it's 2, 3, and 15. Questions? All right.
Yeah, I didn't use it. You can get it, like, I believe in that.
What? Pass up.
Good, but I know what I did wrong.
That's all we want.
Yes.
I'll just say you learn more when you get something wrong, and you're like, why did I get that one wrong? And you figure that out. You learn more from that than when you get something right, in my opinion. All right. While they're all doing that, look at the schedule. This is according to Jenna, so if Jenna got this wrong, then you're going to the wrong places. So we finally hammered out everything. This is what semester finals will look like. So semester finals will be the entire week. No, not just 4 days.
Okay.
So on Monday of that 3rd week, so basically 2 weeks from whatever, right? You will be going to whatever you're taking period 7 for 7th and 8th period. So you're going to go to a full day of classes now, not a half day.
What?
Full day of classes on that Monday. It was already going to be a full day. But 7th and 8th period are no longer 7th and 8th period. They're just 7th period semester final. So on this day right here, whatever you have as your 7th period, that's your semester final. If you're, I don't know, what do you got for 7th period?
Art.
What do you got? What do you got?
Art. Well, I mean,
We
there's
all
Other
have
people,
art.
no, other people have something else.
We all have art.
All the
just
10th
different
graders have
art.
Yeah.
Literally, all you took the same elective?
No,
there's
ours
2
is
different.
different.
Okay, right, but I'm saying you got 2 different teachers. So you need to talk to Mr. Surratt and Ms. Skittle, right? If they decide they're going to do a semester final, you got a semester final. If they don't have a semester final, then you're going to sit there with them until the end of the day. Okay?
fun.
All right. Then, are you paying attention, Danny? From Tuesday to Thursday, you're going to have 2 finals a day. So on that first Tuesday, it's going to be period 1, period 4, whatever your electives are for that French and or Spanish and something else.
Yeah. That's
P or music.
Right. I already know PE isn't going to have a semester final, so you don't have a semester final.
If she did that, she should have done the The pacer test.
No.
I haven't seen that in a long time.
No.
You could give her some hints there.
We should do it.
But it's going to be period 1 and period 4, right? On Wednesday, it's going to be your math final, me, and your chemistry final. So that's a tough day there. Math and chemistry. Each one of these days, from Tuesday to Thursday, you come in, 7:30, 5:40, whatever. You're going to go to your student advisement teacher for 30 minutes. That's your last chance to, let me cram for the semester final, or let me just sit there and catch my breath before we take the final, right? Then you're going to go to your finals class, whatever that is. You take your final, right? I forget what time it is, but it's 90 minutes, 90 minutes final. I don't give 90-minute final. I give about a 60-minute final for an average student. You're an average student. Most of you are average students here. 60 minutes. If you think you're a smart student, you'll be done in about 45 minutes or so, right? If you think you're a slow student, you're going to be doing something for all 90 minutes, right? I write a test so that every single student in this class can finish it in 90 minutes, right? If you think you're a fast student, you're going to be done well before 90 minutes. But if you're a slow student, you're going to be sitting there with a test for the entire 90 minutes. I always give, you guys all had me before, I give multiple choice tests for finals. The only time I give a multiple choice test. So I give a multiple choice test for finals. That's both good and bad. Good thing is, well, the answer is one of those 4. The bad thing is I give no partial credit. Some of you have a C right now because of partial credit. Like, oh, you did pretty good. I mean, in general terms, it's somewhat of an easier test in the sense of I'm not going to make let's make this as hard as we can. I'm going to make it as easy as I can, but it has to cover everything from the first day up until, the end of chapter 7. But it's going to be everything. For me, we're going to do these 2 days. I forgot to change that. This is not going to be Algebra 7 review. This is going to be a semester final review. Semester final review here, semester final review here, and semester final review here. Because this is the full day. So when we get here, we'll do chapters 1 and 2, 3 and 4, 5 and 6. Okay? You're going to go that all the way through the end of the day. You take your first test, then you go to student advisement for 30 minutes again. Eat a snack, take a break, or study, right? And then you go and take your second test. When that's over, go home, right? Dismissal is at 12 every day other than that Monday. So the dismissal half day, dismissal 12, dismissal 12, dismissal 12. If you've taken all your tests by the end of the day, Thursday, guess what? I'll see you next year, right? You don't have to come to school on Friday. Okay? If, however, you had your orthodontist appointment on Thursday and you missed your history final, guess what you're doing on Friday? You're coming in, taking your history final, and then you're going home. No, you don't need to wait to 12 to go home on Friday. You're going to come in, you're going to take whatever test you missed, and then you're going home. Question, please?
Is there going to be a proof?
I will have a proof, but it's going to be multiple choice. I mean, what I'll do is ask you here's the step, right? What's the justification? A, is it angle addition postulate? Is it theorem 3.4? Something like that. Yeah.
So,
do what?
Yeah.
Book of truth, always for me.
Oh, thank God.
Yeah.
Okay.
For you, yes. They will walk around with you the entire day. Exactly. Semester finals is how many people are not going to college? Okay, so then this is going to be the only time that you ever see semester finals. For those who are going to college, this is how college works.
I don't like college.
I remember taking classes in college. Now, college goes on a semester basis. You don't go for a full year. You go for a semester. Obviously, you can do 3 semesters a year if you want. Fall, spring, and summer. It's up to you. They don't have summer school like we think of summer school. They're just a regular semester. When you go to a semester, right, you take 1 class, right, or however many classes you want to take, but you just go for Monday, Wednesday, Friday for math class type thing for 2 hours or something. And then you do that from August until December. At the end of December, they give you a semester final. Not a math class, but I've taken classes in college where there are only 2 tests for the entire semester, a midterm and a final, right? That was it. That meant from August through December, you only had 2 tests. Except that those 2 tests were your only grades. If you fail one, you've already failed the entire semester. So it can be a good thing or a bad thing, But yeah, this is how it works for a higher education. Is you have a semester final. Semester final is when you show that you've mastered all the material that's been taught to you.
There's no homework.
For what?
School is for college.
There's crazy amounts of homework, right? The difference is that in college, quiet please. The difference is in college, the level of caring of your instructors goes completely to zero. Like if you show up to my class and you fail, for me, as a high school teacher, there's something that I worry about. I'm like, oh, Matt's failing. I better help him out. I better make him go to tutoring. If you start failing in college, guess what? They just take your money.
I'm using my money.
You just paid $8,000, $10,000 to fail. Congratulations. The college will take your money happily and let you fail. Right? And I mean, obviously, there's plenty of college professors that do care, but I'm saying the level of care is not the same as it is in high school. So is there homework? Sure. Some homework is graded. Some homework is, they'll say, hey, you show up on day one. By the way, they say something like ridiculous, like I need you to read chapters 1 through 2. And it's common, right? I need you to read chapters 1 through 2. Come to class and like a lot of times you only meet twice a week, 2 days a week. That's it, right? So it might be like I don't know. And classes are generally far longer than an hour, but shorter than 3 hours. But usually like right around the 2 hour mark, hour and a half, something like that. So you come to class and like, okay, I know you guys read chapters 2 through 3. Any questions? Okay, moving on. Right? I mean, it's a whole nother level of you taking charge of your education if you're going to college, right? Other classes are like a math class. Typically, we would meet 3 times a week for about an hour and a half. There'd be a homework assignment for every class. The homework would be about, I don't know, 8, 9, 10 hours of homework.
Jesus.
But remember, you're only doing generally 4 to 5 classes a semester. So that means there are days when you don't have any school every week. Like I think I've told you this. I always arranged my schedule so I never had class on Friday. Like I would not sign up for a class. There's a couple semesters where I couldn't make that work. But I tried my hardest to only, because you get to sign up for classes. And it's up to you to sign up. No one comes and says, like we do here in high school, we're like, hey, you got to take this class. Hey, you forgot to fill this out, right? If you only sign up for 0 classes, they don't care. You sign up for 1 class, they don't care. They do care if you sign up for 10 classes. You got to get special permission for things like that. Nobody signs up for 10 classes. But if you try to sign up for too many, you got to get special permission. But yeah, there were plenty of semesters where I had no school on Friday for the entire semester. So I had 3-day weekend, everything. You need the time because, like I said, generally speaking, you get hours of homework, right? And that's why it's college. It's supposed to be more challenging. It's a different level of education. But I mean, this basic rule of thumb was for every hour of class, you got 3 hours of homework, right? So for a math class, 2 to 3 hours. So we would we would meet like Monday, Tuesday, Thursday, or something like that. The worst ones were Monday, Wednesday, Friday. But you'd meet. The professor would say, all right, any questions on the homework? Again, I try to do mine like most college professors. Any questions on the homework? They go over that. They introduce some new material, and they say, all right, see you later. And then you're free to go. Sometimes I would only have 1 class a day. 1 class a day. That was it. But you got to do your homework. So you get this incredible amount of homework. And the material is obviously hard as well, too. I'm way off topic here.
Yeah.
All right, but it's a good discussion.
Is the homework graded?
For math, it always was. I never took a math class where homework was not graded. There are some degrees where you don't have to take any math, right? But most degrees require you to take at least a math class, as in most degrees require you to take at least a English class and a history class. I know for mine, I got a math degree, Bachelor of Science in Math, and my math degree required me to take 3 English classes, no history classes whatsoever. It depends on the college you go to. But I had to take 3 English classes. I was able to, because of the classes I took in high school, get rid of 1. And then I had to take 2. So I took a writing class, I took 2 writing classes, except one was like a writing / literature class. But I basically said to myself is not that I don't like English. I just said I want to take a class that's in English that guarantees me an easy A. So when you go to college, you kind of put the feelers out. And you're like, well, hey, what's an easy class to take in English? And so it would give you these, like if you had a math degree, like you can take this course. It's your choice. You got this menu of items you can take from. And so I would just ask my math friends, hey, what's the easiest one? So one of the easy ones I took was called business writing. So you wrote papers like you were in a business type thing, and it told you how to do that sort of stuff. And the other one was that you're going to hear these things like something 101, something 201, 301. Those refer to freshman, sophomore. If it has a 1 in front of it, it's a freshman. 2, it's a sophomore class. So I had to take a basic English class 201 in English, and it was pretty simple. But what's up?
Are you saying that in college you actually learn things you actually use?
No, that's not true either, right? There were plenty of classes that I took that I've never used before. By the way, I took 2 classes that I will be using. I took a couple of astronomy classes, and I'm going to teach astronomy next year for an elective.
Yeah, life is fun.
But I also took a class in.
Judging by the stars, it's better rain.
Yeah, we're talking about.
I took a class in computer code writing because I was interested in it, and I've never used that absolutely in my entire adult life. Although as a hobby, right, I'm interested in the stuff, but I've never had to write code. I took a class in code writing because I knew it was going to be easy because I was good at that stuff. But there's plenty of things. The nice thing about college is the number of electives, no matter what college you go to, are so vast and wide that what you generally get these what are called free electives. We have that here in high school as well too, but we just have a limited number of them. But you get to literally, like you said, pick something you're just interested in. I was interested in astronomy. I didn't think that I would ever teach astronomy. I just wanted to learn more about astronomy.
Is there a fantasy group? D&D?
I don't think I've ever seen a class on that, but certainly literature-wise. But your basic question about math, generally speaking, you have to take at least college algebra for most degrees. College algebra is pre-calculus. So if you choose your senior year to take pre-calculus here, you're going to see exactly the same course in college. For me, way back when I was in the Army and I was taking college classes just because it helped you get promoted, I took a college algebra class simply because it was easy, right?
Well, what was your MOS?
I started off as 31 Mike, then I was 18 Echo, and then I finished up as an 18 Zulu. Right. All right, we got to do some math. Here we go. Write down your homework. What?
No.
Yeah, now you're looking like me. Now you're looking like me.
Except I actually remember my question.
Oh.
So, for us in this class, we'll be able to take pre-calc.
Yeah, absolutely. Absolutely. Many of you will choose to take pre-calc because it looks good. You get into a good college. Others of you are like, nope. Algebra 2 is the highest level of math that you are required to take at this high school. That's next year. However, we have a requirement of 4 years of math to graduate. So your 4th year, for those of you that want to take pre-calc, absolutely, take pre-calc. Others of you are like, nope, we're going to offer I'm not saying an easier math course, but a different type of math course. It's probably going to be probability, it's pun intended. It's going to be probability and statistics. And it will be taught at a level that is, and the concepts are much easier than a pre-calculus class. Yes?
Cool question. So, for statistics, could you just build up like some team in a video game and just use statistics to write a board out or something? Would that count in the math?
Sure.
Would it? Really?
Oh,
So I could just play Pokemon.
You'd have to get statistics, though.
So would that be like a mixture of math and literature? Because
No.
statistics has a lot to do with it.
No. It's straight up math. But it's the math of, say, for instance, you get to learn, well, it's probability and statistics. So, how do they figure out, you turn on the television, you heard claims like this one is so much more effective. This particular medicine is so much more effective than this other one. Well, how do they figure that out?
Math.
Yeah.
With statistics, right? Or you've seen this standard thing like they say, oh, you're rolling dice, and you're playing Dungeons and Dragons, and you got to roll snake eyes. What's the probability that you're going to roll snake eyes, right? People throw out these numbers, they just kind of make them up off the top of their head, but there's actual math behind it. So I always found probability statistics besides add, subtract, multiply, and divide in my adult life, other than being a math teacher, as the most useful math that there is.
Okay.
All right, here we go. Now, I've got off on a tangent because today is, okay, yesterday was a medium class. Today is an easy class. All right. Or I should say it's easier, but it is definitely new. It's new stuff. You do have to pay attention. So here we go. Hey, think about this. We got a triangle ABC, right? You guys all familiar with PowerPoint? Yes? In PowerPoint, when you have a shape and you click on it, what happens? It looks like that, right?
Yep.
And then if I put my mouse right here and I drag up here, what happens?
Big.
Pieces.
Right? You get. Now, I want you to notice, though, that they look
Similar.
They actually
One
do
of them
look
has
similar.
one of
We
them-
have this concept of similar in math, and that's what this chapter is all about, by the way. It's similar shapes. Okay? But that's the basic idea, is that we're going to have two shapes that have the same, well, it's got the same shape, but different size, different dimensions, right? Okay, so write this down, please. This does not have to go in your book of truth, right? But we're going to be using this word similar. Now, obviously, it's got a math definition. It's two polygons, right? And by the way, we can have similar circles as well, too. All circles are similar.
Yeah, you can't have a circle.
So we're going to restrict it to polygons. Two polygons are similar if their vertices, that means the corners, can be paired. That means you take one shape and you match it to the other shape. So if you can match their corners, their angles, so that the angles are congruent, all of them, right? The ones that match up, and that their sides are in a proportion, then you're allowed to call them similar. This is the symbol for similar, 1 tilde. 2 tilde means approximately. 1 means similar. This is a complicated definition. It's not friendly. It says two shapes are similar. Dan, have you written any of this down? Two shapes are similar if you can match them up so that their corresponding angles are congruent. Notice we have the word congruent in similar. It's the only thing that's congruent. It's their angles. Their angles are going to be congruent. Their sides are going to be proportional. Angles are going to be congruent. Their sides are going to be proportional. And if that's the case, then you get to say they're similar. You get to put the one little wiggly thing next to them. This entire chapter is going to be on similar shapes. Today's an easy day. Tomorrow will not be. And the reason why today is going to be easy is because we've already done something, I will use the word similar to this for polygons for congruency. It'll seem very familiar what we're about to do. So two polygons are similar if their vertices, that's their corners, that's their angles, can be paired together so that all the corresponding angles are congruent and the corresponding sides are proportional. Proportional means it makes a ratio. Hey, we've been doing ratios. We okay? All right, picture's worth 1,000 words. This is what it means. This triangle, ABC, is similar to triangle, one tick mark. You remember how this is called from pre-algebra? It's one tick mark. We say A. Anybody? Remember? A prime. Two tick marks, we would say A
Alpha.
double prime.
Oh,
3 triple prime. Okay.
alpha.
So this triangle right here is similar to this one, Danny. Eyes on the board. This triangle is similar to this one if we can match the corners so that the angles are congruent and the sides are proportional. Do you remember what this was called for congruency? This was called a, this statement right here was called a what? When it was congruent, we called it a congruency statement. So this is going to be called a similarity statement. Okay? Now, if they are similar, by the way, it tells us they're similar, the statement right here. It says they're similar. That means all their corresponding angles are congruent. That means angle A is the same as Angle A prime. Angle B is the same as B prime. That's just the angles. The angles are going to be congruent. You can also get that from the similarity statement. Remember doing this, chapter 2? A is your first letter, it matches up with the first letter. B is your middle letter, it matches up with your middle letter. Okay? So I can make this statement right here because they're similar. Look at the board. I can make this statement because they're similar. A goes with A prime, B goes with B prime. It's not because A goes with A, it's because of the similarity statement. You can also get it from the picture, but you got to be really careful. Because remember, they can take, look at me, they can take that triangle, they can flip it, and they can turn it, right? So don't always rely on the picture, rely on this similarity statement. Now here's the new thing, this is new. We said that the sides are in a proportion. Here's what that means. Wes, pick a side on this triangle. AC. So AC, side AC, remember that's a segment, goes with what side on this triangle? AC would go with A prime, C prime. It says a proportion, so a proportion is a ratio, so we put A prime, C prime, with a line over the top. That's messy. Okay? But how many sides are there? How many sides are there?
On the triangle?
Yeah.
3.
So therefore, how many ratios are we going to have?
3.
We're going to have 3 of them. There they are. It also doesn't matter which one you started with. I chose AC. You could have chosen a side off this one, and that could be on the top. Okay? So this is what this entire day is about. This right here is the fact if you have similar polygons, that the corresponding angles are congruent, and that the sides are in a proportion. Proportion just means a ratio. Ratios that are equal to each other. Okay? Tonight for homework, they're going to give you 2 shapes. They're going to say, give me the proportions, give me the congruent angles. How are you going to do it? There's 2 ways of doing it. The easiest way is to look at this statement. The harder way is to look at the 2 shapes, because the 2 shapes can be twisted and turned. Okay? So, first skill is to do that one. You got to identify the corresponding sides and the proportional sides. Here we go. I'm going to use the same shape, 3 different problems. Danny? It says you get 2 things from similar. You get congruent angles that correspond to each other are congruent, and you get proportional sides. Pick a shape, left or right, it doesn't matter which one you want. This is box 2. We're going to look at the right one. Pick an angle. Okay, Y goes with what angle on the other one? How do you know that? Okay, can you get that from this statement right here? Yes, you can. Where is Y on this statement? And then what letter is it? What's the 3rd letter over here? 2 ways of doing it. You can certainly get it from the picture, but you got to be careful. Pentagons are easy. As soon as I give you an equilateral triangle and I twist it and turn it, I'm throwing a loop. I would always, always, always look at your similarity statement. Okay? So we got our first one. Y goes with S. Matt, give me another one. P goes with V. Chris, give me another one. Give me another one. Congruent angles. R goes with X. All right, give me another one.
W.
Goes with
Q.
All right. So the congruent angles are pretty simple. I'm going to warn you, I would always, if they give the similarity statement, go with the similarity statement. Don't try to pick them off the picture. You're like, well, that's silly. This one's easy. This one is easy, right? But if I take this one, look at me, and I flip it like this, then you don't know which one goes with which one. And it doesn't mean that this one always goes with this one. Do you see what I just did? Imagine this was flipped. X doesn't go with T, X goes with R. So this will always tell you the truth. The picture may lie to you. Proportional sides are the hardest one. Danny, pick a side, left or right, it doesn't matter. Okay, give me a side. A side. TP. Notice what you picked. You picked T, that was your first pick. That was your second pick. TP would go with what side on the other one? Okay, TP would go with not DC. You said TP. That would go with same pattern. ZV. But you got to write it as a ratio. So when you write that, TP fraction bar goes with, and you said what, ZV? There you go. That's what you'll have to do tonight for homework. You tell me, easy or hard? That one's easy. That would equal, now he went from small to big. Wes, pick me on the other side. RQ goes with somebody. So I put RQ XW. Now you get to pick whether you went from left to right or right to left, because it could be done either way. Got a question, Matt?
Why are they congruent?
They are congruent because when things are similar, check this out. Here's an angle. I'm going to draw exactly the same angle right there, right? I'm going to draw a triangle. I'm going to draw a similar triangle. Did this angle ever change? That's why they're congruent. Clearly the sides are not congruent though, right? They're proportional. Okay? Good question. All right, there are all your things, and hopefully they don't give you a pentagon tonight for homework because that's going to take you a long time. Okay? Could you do this yourself? Everybody? Connor? Pretty simple, right? All right. So do it one time. I gave you a triangle, not a pentagon this time. Box 3, give me all the congruent angles. Give me all the proportional sides. One time. We'll do this one time. Box 3 on the sheet in front of you. Give me all, notice there's no picture now because I'm trying to reinforce, use the similarity statement. Don't ever use the picture unless you have to. And you will have to use the picture occasionally tonight for homework. Chris, you already done? Box 3, you already done? Micah, you already done? Box 3. Danny, you done? Connor, you done? You got the angles? Give me the angles, Connor. Keep going. There's 3 of them.
Angle X is 3 D.
So if you didn't hear me, he said A to G, D to H, and X to Z. That's what I got as well, too. All right, Danny, give me one of the fractions. A what? Okay. So, Danny, these 3 letters right here refer to a triangle. A, D, X. Give me one side of that triangle. A is an angle. Give me a side. That goes with, can you do the other 2? It's a triangle. It's got 3 sides. One more. Perfect. Perfect. Now, did he have to start with these letters? Could he have started with the other triangle? So there's 2 possible answers. I gave the one that Danny gave, right? But you could have also started with these, and those would be on the top. Doesn't matter. Okay? But once you stick with one pattern, you got to stick with that pattern. You're going left to right, you got to go left to right for all. If that makes sense, left to right. So on. Okay, write this down, please. Scale factor. If you take one of those fractions that we just did, and we actually plug in the numbers, the size of those sides, hopefully that came out through a math, all right. We take the number, like how long it was on that side of the triangle. We take one of those fractions, and we write the numbers for the size of the sides That gives us a scale factor. So it says ratio, there's your fraction, of the lengths of two corresponding sides. It's got to be corresponding sides. You can't just pick any two sides. It's got to be corresponding sides. Basically, what you just did, one of those fractions, whatever that results in, whatever those two numbers are, that's called the scale factor. That's how much that the triangle has either been increased by or decreased by, depending if you went from left to right or right to left. So check it out. It said any corresponding side. What do you want, Matt? Left or right? Give me a side on the left.
C flat A.
That's on the
Wait, that's on the right. Sorry. CA.
CA. So if we want to do a scale factor, CA corresponds with, okay, there's your scale factor. You're like, there's no numbers there. Yeah. Your job now is to put numbers there. In other words, you got to find distances. The distances will be given to you tonight. So that will be your scale factor. I don't know which one I picked, but I picked. I picked AB. All right. If you need a formula, SF stands for scale factor. The length of shape 1's corresponding side over the length of shapes 2. Okay, that's a lot to write. The idea there is what we just did. You pick one, left, it doesn't matter. You're like, yeah, but the scale factor were different. Agree. You go from small to big, you're scaling up. You go from big to small, you're scaling down. So technically, there's two different scale factors for any similarity statement. One to scale it up, one to scale it down. They will be reciprocals of each other. It's going to be crazy simple. Okay? We good on this definition? Let me give you an example. Hey, back to our pentagons. Hey, there's only two sides that are listed that have actual numbers. So we're going to figure out our scale factor. Where do you want to go? Little to big or big to little? We go from little to big, right? They were scaling up or scaling down. So we need big to small. So if you go from big to small, that would be what? No. If we're going, we want to say, how much are we scaling up to? We need a number bigger than 1, right? So that means we got to start with the larger one first to the smaller. So it's kind of opposite of what you think. So what's the size of our larger one? What's the size of the smaller one? So I'm claiming that the scale factor is that we should probably reduce that, right? So what would that reduce to? Which will reduce to? I'm claiming that it's 8 over 5. Oh, who's got a calculator? Pull your calculators out. Divide 8 by 5. Ooh, I'm going to show you magic. Divide 8 by 5. What do you get? 1.6. I'm claiming that the scale factor is 1.6. You ready for the magic? Multiply 20 by 1.6. What should you get?
32.
Isn't that crazy? So this one, the smaller pentagon, has been scaled up by a factor of 1.6. I said that they're just reciprocals of each other to go the other direction. If we want to scale down, you write small over big. That would give me what fraction? Guess what that reduces to? Take a guess. Okay. Calculators, divide 5 by 8. What do you get?
0.625.
Anybody want to take a guess what 32 times 0.625 is? 20. Isn't that crazy? That's pretty cool. All right. I'm going to show you now what I just did. E-learners didn't see any of that because I wrote it on the board. Here's how you figure out scale factor. You pick any two sides that you have numbers to that correspond. I just can't pick any two sides of the two. I got to pick corresponding sides. So for instance, PQ goes with VW, and I got numbers for those. This was the math that we just did. Hey, is that going to be bigger or smaller than 1? Look up here. Is this bigger or smaller than 1?
Bigger. No.
5/8 is bigger than 1?
No, small, my bad.
Right? If you get a number that's smaller than 1, are you scaling up or scaling down? You're scaling down. That's how you go from the large to the small. But look at the fraction. You would think to go from large to small, you put 32 over 20. It's the opposite. It's 20 over 32. But this number right here, 0.625, is how you would get from 32 to 20. The opposite of this whole thing, scaling up, right? You would think that for scale up, then we would go small to big. No, we go from big to small, right? So we go 32 over 20. Once again, the fraction would give us a number bigger than 1. That's how you get from the 20 to the 32. You multiply 20 times 1.6. That goes for all the sides. For instance, I don't know, I'm making this up. If SR is, it looks like it's smaller than 20. Let's say it's 14. Guess how big this one is? Go ahead, calculators. Somebody do it. Somebody. There's 3 people with calculators in your hands. Tell me the answer. Tell me the answer. We said that SR is 14. How big is YX? What is it? 22.4, apparently. Okay, that's how it's done. So how many times do you need to figure out scale factor? 1 time, as long as you understand this method right here. Now here's the only kicker. Look up here. If I tell you the scale factor is 0.625, you can't get to 1.6 from that. If I tell you the scale factor is 5/8, you can get to the other one really easy. So it's usually easier if we say the scale factor is a fraction rather than a decimal. Because as soon as we convert to here, I've lost the fact that how big the other side is. You can, right? But then there's extra work there, right? It's easier, just leave it as 5/8. If you do this, 1.6, then we got to write what 1 6/10. That would be 16 over 10. I mean, there's a little bit of work involved, okay? So it's easier if you leave it as a fraction. Tonight for homework, leave your scale factors as a fraction. It just makes your life easier. Okay. We got one thing left. We got what? About 8 minutes to do it. Everyone needs to do this slide. This is your homework. Like all your homework's going to look like this slide. This is going to be a very messy slide. Let's do the work. Here we go. There's only 4 quick questions. Tell me the scale factor, calculate how big X, Y, and Z are, tell me the perimeters, and give me the ratio of perimeters. It seems like 4 easy questions. It takes a little bit of work. I don't know what the shape is, except that it's a quadrilateral. Like, I don't think it looks like a trapezoid. It could be. I don't know. Probably not. Okay. Scale factor. We find a scale factor by picking any 2 corresponding sides. So here's what you got to do for homework. Choose wisely. Seth, choose wisely. Which 2 sides do we want to compare?
1/3.
DC and D prime C prime. Okay? Does it matter how we write this ratio?
You get to a fraction.
Doesn't matter, right? We just need to write it. We pick and choose. What do you want to go? Small to big or big to small? We're going to go big to small. I went the other way. All right? So we'll choose this method. We're going to go big to small. So we're going to write 30 over 20. So the scale factor is 30 over 20. Reduce, that's 3 over 2. E-learners aren't going to be able to see this one. I did mine. I went, actually, let's do small to big. That way the e-learners can see this. So if I went from there, I get 2/3 instead of 3 over 2. We okay with defining scale factor? Pretty simple, right? Done with that one. Now we're going to find X. Where's X? On the big quadrilateral or small one?
On the bottom.
On the big quadrilateral or the small one? Small one. What side corresponds with AB? What side? A prime, B prime. So if we were to set up that ratio with that X, what would I write? What would I write? If I set up that ratio with the X, what would I write? Okay. So X over 21, right? What do we know about similar shapes and scale factors? All of the sides will be 2 to 3. So guess what I can write next to this?
2 over 3.
And then solve the proportion. Who's lost on what I just did? That goes for all the sides. All the sides will be in a ratio if you go from small to big. 2 to 3. You go big to small, the ratio is going to be 3 to 2. By the way, could you solve this proportion? 14. 2 times 21 is 42. 42 divided by 3 is 14. Hey, we didn't get to finish this slide. This is what your homework looks like. I'm going to come through during student advisement. Make sure you do your geometry homework, so if you have any questions, I can help you. E-learners, if you have any questions, make sure you ask. All we did there to find for x is we solved the proportion. To find y and z, we do the same thing. We set up a proportion and simply solve it. I believe the other two questions, perimeters and ratio of perimeters, are pretty easy. All right, Isaiah, any questions? If not, I will stop class and see you tomorrow.